so sorry I lied to you. I thought we were done with quadratics for the time being, but here they are again. Yay! Okay. This is more related to graphing quadratics, looking at their x and y intercepts, their vertexes, and their zeros. Not so much factoring them necessarily. So this might be more aligned with what you did in Math 3. I'm not 100% sure because I never actually taught Math 3. Or you did this, I know, like probably the last week of Math 2. So we're going to use the table of values for a quadratic function. So table of values is a quadratic function to identify the zeros and the x and y intercepts of the graph. So zeros are where I cross the y-axis, or the x-axis, I'm sorry. So where y equals 0, so my zeros are here and here, where I've highlighted in yellow. Ignore the green one for now. So zeros are negative 2 and 4. They're also my x-intercepts. So I don't know if I said that wrong. I can't even remember what I just said. Okay. Where I've crossed the x-axis, where y is 0. Okay, sorry if I got you confused. Ignore what I just said there. So one more time, x-intercepts and zeros are the same. X-intercepts are just a coordinate where you're crossing the x-axis. So when y equals 0, what does x equal? And then the y-intercept, you'll only ever have one of them if it's a true function, because you can only cross the y-axis once. My y-intercept is where x equals 0, because that's where you're crossing the y-axis. So again, highlighted in yellow, 0, negative 8. Now, what do you notice about the smallest function value shown in the table and its location? So that's what's highlighted in green. It's my smallest function value, although I don't think I would ever actually call it a function value. I don't remember ever hearing that term ever. I probably would have said like the lowest point or the lowest coordinate or the smallest coordinate, not smallest function value. So if that tripped you up, don't worry. It tripped me up too the first time I went through this, and I was like, what's a function value? Just because that's not a term I'm very used to hearing. So the smallest function value, or the smallest point, lowest point, is 1, negative 9. It is in the middle, not necessarily in the chart, but in the middle between the x-intercepts. So it doesn't necessarily need to be in the middle of the chart, so don't get that confused. It's just the point in between. Oopsie. If I erased that y-intercept, see how it's right in the middle of them, like equal distance. The y values are symmetrically formed around it. So my y values increase at the same constant, rate around it. Or I guess that's not the right wording. Okay, if I drew a line here, like negative 8, negative 5, negative 5, 0, 0, 7, 7. That's what I mean. Sorry about that. Okay, so moving on from all the mistakes that I just made in that problem, I apologize. Hopefully you didn't get too confused. In case you forgot, a quadratic function is a U-shaped graph, also referred to or known as a parabola, and the turning point of the parabola is known as the vertex. Okay, so there's a nice little picture for you. Example, use the table for a quadratic function to graph the function. And usually I don't go over examples, but I did want to go over this one just because I think quadratics are something that we all struggle with, or at least we did last year. So identify x-intercepts and the vertex. So where do I cross the x-axis? Oh, okay. Here are my points. Okay, vertex right there at the very top. So I could have either looked using the chart, or I could have used looking at the graph, what the vertex is. The vertex is between the two zeros, solutions, or x-intercepts. They all mean the same thing. Those are highlighted in green. They happen right in between them, okay? And then I'm going one step further. I'm going to do the y-intercept as well. Y-intercept correlates with that guy right there that I had highlighted, where I cross the y-axis, or when x equals 0. I have two x-intercepts, one y-intercept, and one vertex. That's pretty typical of what you'll see. Once in a while, you'll get something a little bit different where maybe you don't have any x-intercepts, but typically this is what you'll see. So copy this down. It's a nice reference for notes, especially if you've color-coded it. So here's the quadratic formula again. Quadratic formula helps us find our zeros, our solutions, or our x-intercepts. And I use all three of those terms simultaneously so that you know that they are in fact the same thing. They all mean the same thing. So if I asked you to find the zeros, if I asked you to find the solutions, or if I asked you to find the x-intercept, it's all the same thing. So don't get confused by that vocabulary. I would plug in my my A's, my B's, my C's. Literally plug it into Desmos. I'm not asking you to actually hand calculate it to find those zeros and x-intercepts. If you want to find the vertex using that same A and B value right here. So plug in B, or negative B over 2A. Again, something I'm not going to ask you to memorize, just to make sure that you have these notes kind of handy when you're taking your test so you can refer back to it. Okay, now we're going to move on to number 2, and we are going to use the quadratic formula to find the zeros of the function vertex and y-intercept. Okay, I'm going to do everything. So my A value is 1, my B value is 8, my C value is 11. So quadratic formula, copied and pasted from up above. I plug in B, A's, and C's. And I plugged it into Desmos. I got x to equal negative 1.76. And then if I changed my sign, I got x to equal negative 6.24. So those are my x-intercepts, my zeros, or my solutions. As coordinates, there they are. Okay. Then I'm going to find my vertex. I'm just going to find everything at once and then sketch the graph. So my vertex is negative B over 2A. So I'm using that same A value, same B value, just plugging it into this much simpler formula. And I get my vertex to be 4. But remember, my vertex is a coordinate, not just x equals 4, because x equals 4 is actually all of this. Okay, and that whole line is not my vertex. It's 1 point. So I need the y coordinate, and in order to do that, I plug it back into my my function that I was given. So I'll plug in negative 4 for x and solve. So do the math. Y equals negative 5. So my vertex is negative 4 comma negative 5. So I drew in my vertex point. I drew in my intercepts. I kind of had to estimate because there were decimals and my graph does not go by decimals. And I lied. We did not find the y-intercept. So I just need the x-intercepts and the vertex, and then my beautiful parabola that I drew in there to connect all three of those points. Okay, if you needed a little bit more assistance, here you go. A little bit more broken down with the words for you to look at. Moving on, some more notes. I went into this more if I'm teaching in person. I think on video it's very hard for me to describe, just because I can't really point things out to you. So if you're watching the video, I'm not going to go into depth in this. You'll just have to figure it out yourself. In person, it's much easier for me to explain this. Okay. So number 3, notice that this function, Number 3, suppose a parabola has the x-intercepts of 5, 0 and 11, 0. What 2 factors would be present in the quadratic function? So when we solve this, okay, so like we're working backwards here. So we're saying that x equals 5, x equals 11. Okay, so I'm taking it a step backwards. What is this? Hold on. Equals 0. And this equals 0. Remember, we have an x and an x. What would go here and here to make those x values true? Well, -5 and -11. Okay, so that's how I got those answers. I'm like working backwards. So let me get rid of all that before we move on. All right, perfect. Okay. Multiply these factors to write a quadratic function in its standard form. So I'm going to take this and I'm going to distribute, FOIL, multiply, however you want to say it. I'm going to go this way, this way, this way. Oh, no. This way, this way. Okay, so I'm going to distribute. I would get x squared minus 11x minus 5x plus 55. Okay, and then I can combine my like terms. And y equals x squared minus 16x plus 55. I'm going to skip C, write 2 more functions with the given x-intercepts. I'm not gonna worry about that today. Okay, so let's skip that. We're going to go on to number 4. Identify the pattern in each table as linear, exponential, quadratic, or none of the above. So for this one, we are looking at the differences. Remember, linear, if the first difference is the same, it's going to be linear. And what do I mean by that? Well, when I add up the difference between x values, so how did I get from one x value to the next? Okay, those are all 1. That's good. How did I get to the next y value? Plus 4 each time. So they have a consistent slope that makes this linear. So my first difference are what I added in purple there. First difference makes it linear. Okay, the next one. I'm going to do the same thing, different color this time. How did I get from one x value to the next? I added 1 consistently. My y's, how did I get from one term to the next? I was not consistent. So plus 5, plus 3, plus 1, minus 3, minus 5. Not consistent. Let's go to the second difference, okay? My x's are already like plus 1, plus 1, plus 1, so I'm not going to touch those. I'm just going to do the y values, and I'm going to the second difference. And when I do that, I notice we subtract 2 each and every time to get to the next term. So that is my second difference. First difference, second difference. If it's the second difference, it's quadratic every time. Okay, let's try one more. I'm going to different color. X values, adding by 1 each time. Perfect. Y values, plus 1, plus 2, plus 3, plus 4, plus 5, plus 6. Okay, so it's not linear. Let's do it one more time. Second difference, plus 1, plus 1, plus 1, plus 1, plus 1. That makes this, in fact, quadratic. Second difference is the same. Okay, and then the last one, and then we are done with this cycle. And it'll be time for a summative. Yay! Okay, so this one, again, x values, plus 1, plus 1, plus 1, plus 1. I'm not going to write that down again. Y values. Plus 2, plus 6, plus 12, plus 24, plus 48, plus 60, 96. Okay, that's not working. Okay, let's do second difference. Plus 3, plus 6, plus 12, plus 24, plus 48. Okay, that's not working. Plus 3, plus 12, plus 6, plus 24. Okay, definitely still not working. So it's not the first difference. It's not the sixth. It's not the first difference. It's not the second difference. It's not the third difference. If I do this again, I think you can kind of see what pattern's going on here. What am I doing? I'm actually multiplying everything by all my y values by 2. When I multiply to get to the next term, it's exponential. So exponential does not depend on first and second differences. It is multiplication. If you multiply from one number to the next number, exponential. Okay, so go ahead and give those homework problems a chance.